rates of change and slope a little bit last year in pre-algebra, so hopefully some of this looks familiar to you. But a rate of change is a ratio that describes, on average, how much one quantity changes with respect to another. And the most common rate of change that we use is miles per hour. So miles per hour, we represent it as mph. That's one of the most common ones. It's like something per something. And usually it's for a time period, like miles per hour, minutes per second, money per year, just all kinds of different things. And usually the time is always on the bottom. So let's take a look at an example here. It says, use the table to find the rate of change. Then explain its meaning. Well, if I have a table and I'm finding the rate of change throughout the whole table, there's probably a common rate of change going through here. So all I got to do to find this is just pick like two values. For example, I could pick any two. I could pick I traveled 76 miles in 2 hours, and then pick I drove 4 miles. I drove 152 miles in 4 hours, and then we find the rate of change in between that. And all we do, if we think about this, the time's on the bottom, right? We just talked about that, so it's really going to be miles per hour. So how do I find how much it changed for the miles? We subtract them. 152 minus 76. And then for the time driving, well, in 152 miles, we went 4 hours. And for 76 miles, we went 2 hours. And so now we can find that rate. So how much did it change during those two time periods? And we find out that it is 76, actually, isn't it? 76 over 2, which simplifies into 38. And we put a label on it, miles per hour. So usually mph for miles per hour, but I'm going to go miles per hour, because that's what we do for anything. Just put the slash for per, miles per hour. So we're just finding that rate. And really it's the exact same thing as finding a slope is what we'll find out. The rate of change is really the slope. If I would graph this, that would be the slope of my line. So we'll look at that as well. So finding the rate of change. My next thing is determine whether each function is linear, whether it makes a line, right? Linear means line. Well, to make a line, I have to have a constant rate of change. And I have a constant rate of change, or a slope. So if I think about this, like a constant rate of change, like for here, my x's, it's going up 1, it's going up 1, it's going up 1. That looks like a constant rate of change. It keeps going up 1, up 1, up 1, up 1. What about with my y's? It's going up 6, it's going up 6, it's going up 6. So if I graph that, you think that would make a line? You bet it would. It's got a constant rate of change, right? Every time it goes up 1, the y's go up 6. That would be a constant rate of change. It would make a slope. It would make a line. What about the next one? For my x's, I'm going up 8. I'm going up 8. I'm going up 8. So far, so good. So far, so good. Let's look at the y's. See, I'm going down 4. I'm going down 5. I'm going down 6. Would that make a line? I don't know. Every time it goes up 8 in the x, it's going down an extra one. That's not, I don't think that's going to make a slope, is it? So let's get into slope. We've done the rate of change. Slopes and rates of change are the exact same thing. And if we think of slope, it's always the rise over the run. I don't know if you remember learning that last year. If you did, hopefully it's clicking for you. Remember slope, we use the symbol M for slope. We use the letter M for our variable for slope. And it's the rise over the run. The rise over the run. So if I think about the rise, that's how it changes in the y's, right? The rise, the up and down are my y's. So how much it changes in the y's. And so I have 2 points here. So if I found the slope between 2 points, what would happen is that I would subtract my y values on top, right? y2 minus y1. So I'm subtracting this one by that one, y2 minus y1. because it's the rise. The rise is always on top. And I'm going to subtract it over top of my run. So the run would be how it changes in the x direction. So x2 minus x1. So we just subtract our x's on bottom, because that's the run, right? How much it goes left and right. So you can pick any 2 points in your graph to find the slope. So let's find some slopes here. Find the slope of the line that passes through each pair of points. It doesn't really matter which one you pick is x1, y1, and which one is x2, y2. But it does matter which one how you start it. So for example, let's look at number 1. If I subtract my y's on top, right? Rise over run. I'm going to put that up here again. Remember, it's rise over run. So we got y2 minus y1 over x2 minus x1. So I can take 5 y2 minus y1 over x2 minus x1. Well, and minus a negative 3 is really adding a positive 3. So I get 3 over 8, and I'm done. Looking at number 2. Same thing. Subtract my y's on top. So negative 8 minus negative 4. And subtract my x's on bottom. And since I started with negative 8 to subtract on top, I got to start with negative 2 to subtract on bottom. You got to start with the same point. So negative 2 minus negative 3. Well, minus a negative is really adding a positive. So negative 8 plus 4 is negative 4. And negative 2 plus 3 is positive 1, which simplifies into negative 4. Slope of negative 4. How about 3 and 4? 3 and 4. Let's look at 3 first. Well, subtract my y's on top. So it doesn't matter which way. 4 minus 4. And since I started with this one first, let's start with this one on the bottom. Negative 3 minus 4. We'll see what happens. Well, I got 0 over negative 7. Well, 0 divided by anything is 0, isn't it? 0 divided by anything is 0. So this has a slope of 0. Is the same thing going to happen over here for 5? I'm going to go ahead and subtract. Doesn't matter which way I start. So 4 minus 2 on top. Subtract the y's on top. Well, minus a negative 2, isn't it? Be careful of that. I almost made the mistake. So minus a negative 2. And then 3 minus 3 on bottom. And minus a negative is really adding a positive. So I have 6 over 0. Is that also 0? Can I break 6 into 0 even parts? No, I can't break anything into 0 even parts. So that doesn't work. We say this slope is undefined. Okay, there is no slope here. And if I were to graph these two guys, number 3, a slope of 0 would be a horizontal line. And undefined would be a vertical line. And I always think of it as my horizontal line here. I could actually walk on this, right? That's a slope I could walk on. So it has a slope. It has a slope of 0. Whereas this undefined one, I couldn't walk on this slope. I'd be falling down if I tried to walk on this slope. See, I'd be falling down. So it's undefined. There is no slope. So that's what I always think of. You cannot divide by 0. So it's undefined. All right, just applying your slope a little bit and using those to find your rates of change in some of your story problems.